Hello, welcome to the 1.5 notes. These notes are on properties of limits. Before we start, we're just going to review some properties of function notation. And so this problem says if f of x equals 15, g of x equals -3, and h of x equals 0, evaluate the following. So if you can't visualize this, just so you know, that means that all of these functions are just horizontal functions, horizontal straight lines. But what you would do with this is if you were trying to evaluate f of x minus 2 g of x, you would just replace f of x with the value it's equivalent to. So f of x is equivalent to 15, then you would do 2 times g of x is equivalent to -3. And then that would be your answer after you work that out. So go through these real quick. Go through these real quick and try all of them out. I'm not going to talk, I'm just going to work through them. Those should be your answers. So that's just function notation. You guys have been doing that since Algebra 1, maybe even earlier, but it's going to come in handy as we do what's new. So I'm going to go on to the next one. I knew it would do that. Sorry, sometimes it just doesn't copy over. But this says if f of x equals 2x and g of x equals x plus 2, find f of g of 2. So this is called a composition of functions because we have one function inside another function. And this will be really popular later in algebra, but we're going to use it a little bit right now. And so what you'll do for this is you'll start by finding the value of the inside function. So I'm going to start by finding what g of 2 is, and my function g of 2 is x plus 2. So I'm just going to input 2 for x, and I get that g of 2 equals 4. So I'm going to do f of 4 because that's what g of 2's value is, and then I will plug in 4 for the function that represents f of x for the equation. So I'll do 2 times 4, and that equals 8. And so the answer to f of g of 2 is 8. And again, that is just some function notation practice. Now we will get to how this involves the property of limits. So I'm going to go through these real quick, and then I will show you some examples of them. But these are our general properties of limits. This says let b and c be real numbers, let n be a positive integer, and let f and g be functions with the following limit. So as we approach the limit of f of x as x approaches c is L. So we don't know what c or L is, but it doesn't matter. And this one says the limit of g of x as x approaches c is k. So just one thing as we do these problems, these rules that we're about to learn only apply if our two different limits are approaching the same number. If one of them was approaching 3 and one of them was approaching 4, you couldn't use any of the properties. They have to approach same value. That's not how you spell approach. Approach. Same value. So that's just a key. So this first one is the scalar multiple one. It says the limit as x approaches c of b times f of x is going to be b L. And you're just going to multiply those two. And b is just going to be some kind of finite number. It's not going to have any variables in it. It'll be like -10 or 2 or 3, something like that. And I'll show you more examples. Sum or difference rule is that the limit as x approaches c of f of x plus or minus g of x is going to be L plus or minus k. So it's going to just be those limits separated, like the limits separately added together or subtracted, depending on whether it's a sum or difference. The product rule is the limit as x approaches c of f of x times g of x is just their limits multiplied together. Quotient rule is the limit as x approaches c of f of x divided by g of x is their limits divided. But remember, this only applies if k does not equal 0, because you can't divide by 0. The power rule is the limit as x approaches c of f of x to the n power is the limit to whatever power n is. So it would be like L cubed or L to the 4th power, depending on what that is. And the last one is different. And so the reason I highlighted this and I did those review problems is these are all really similar to the properties you would use to evaluate a function. But composition is different. You aren't just finding like the limit of the inside and then using that to find the limit of the outside. What you're doing is it says the limit as x approaches c of f of g of x equals f of the limit as x approaches c of g of x, and then like vice versa if they were switched. So you're only finding the limit as x approaches c of g of x, and then whatever you get, you just plug it into f as if it was just like normal function notation, as if it was like f of 3. So you're only going to do the limit once. And again, I will show you more examples of this, but this one is the one that is different than function notation. So if you're ever doing it and you're like, this feels too easy, you could be doing something wrong. Different than function notation. The other ones are the same. So let's go on to some examples. This one says the limit as x approaches 5 of f of x equals 6, and the limit as x approaches 5 of g of x equals -2. Notice they both approach 5, so our limit properties work. We know, I'm not going to write this out every time, but I'm basically going to separate this. What this is equivalent to is you basically can just, based on the difference property, you can just subtract the two limits. So the limit as x approaches 5 of f of x is 6. The limit as x approaches 5 of g of x is -2. So I'll do 6 minus -2, which equals 8. And that is our answer. This one, I'm going to write this out just for this page, and then I'm not going to write them out as much. But what the other rule tells us is that these two limits can just be multiplied to find that. So the limit as x approaches f of x times g of x is the same as the limit as x approaches 5 of f of x times the limit as x approaches 5 of g of x. So that's 6 times -2. That equals -12. And then this last one is an example of the scalar multiple one, because you just have this scalar out front that doesn't have any like variables or anything in it. So I can just basically take that out front, and I'll say that the limit as x approaches 5 of -2 times g of x is equivalent to -2 times the limit as x approaches 5 of g of x. So basically you just do -2 times -2, and it's 4. So all of these things, you're taking these like big, ugly things, and you're just replacing them with their limit value. And so it looks really scary, but it really is the same as doing any function notation. So the problems are going to get a little harder, but I want you to remember that, is it's the same as just doing these with function notation. So this one says, let the limit as x approaches 5 of f of x equals 6, and let the limit as x approaches 5 of g of x equal -2. I think these are the same values from the last time. We're just doing more problems. So this one is concerned about the limit as x approaches 5 of g of x cubed. So we're going to do -2 cubed, and that equals -8. So feel free to work ahead on these next couple problems, and I'm just going to kind of explain them quickly. So this would be 3 times the limit as x approaches 5 of f of x is 6 minus 9. So I'm just replacing, substituting. Equals 9. This one looks tricky, but I'm just going to do 13 over 6, because that is the limit as x approaches 5 of f of x, plus 2 times, okay, so what should I put in for x? That's interesting. I'm just going to put in 5 there, which that might be tricky, but the reason we're plugging in 5 there is because of some algebraic rules that we'll learn later. So sorry, this kind of adds some things that we don't know yet, but if you're ever just trying to find the limit as of something that's not super complicated, the algebraic way you can do it is you just plug in whatever we're approaching in for x. So we haven't learned that yet specifically, but maybe you're kind of picking that up. And if you looked at some of the functions we did graphically, it always works. And I'm just going to leave this. One funny thing about calculus is that on the AP test, you don't always have to simplify. So I'm just going to leave my answer like that. But I'll show you what the answer would be to simplify if you did. Would be 12 1/6. Okay, we'll keep going. Now we have some new limits. So this one says the limit as x approaches 4 of f of x equals 3. The limit as x approaches 4 of g of x is 5. For this one, I think there was probably supposed to be, hold on, something got cut out here. Oh, never mind. That's fine. Sorry. Okay, so those are those ones. So again, when we get to x squared, what you're going to do is, because there's no function or anything there, you're just going to plug in 4 for x squared. That will equal 16. Because if you imagine the graph of x squared, the graph of x squared looks like this. And if you think about where 4 is, well, 4 squared is 16, right? So if you're approaching from the left and the right side of this, you would get 16. And that's an example of when a limit and a function value are the same thing. But we'll get more to that in our next notes. This one we'll do, 3 over 11 times the square root of 5. And we can't really simplify that, so we'll leave it like this. Okay, so if you've been working by yourself, stop, because these are new problems. If you look at all of these are all compositions. So these are all going to take a little bit more thought. And I'm going to remind you, as we do this, what our problems earlier told us is that the limit as x approaches 2 of f of x of g of x. Okay, I got a little paused, so I'm just going to pick up where I left off. But these are composition problems. And so if you go to A, the limit as x approaches 2 of f of g of x equals, so if you go back to what we saw earlier, this is equivalent to f of the limit as x approaches 2 of g of x. And so we'll start by doing the inner function. So we first need to find the limit as x approaches 2 of g of x. Luckily, if you look at this, we have a lot of information. And we don't need all of this information. We're just going to need some of it. But the limit as x approaches 2 of g of x is 2. And then f of 2 is 17. So that's the answer to this one. So you first find the limit of the inner function with respect to whatever the number this is, and then you use that to find the function value. So for the next one, it'll be g of the limit as x approaches 2 of f of x. So I will go back to all of my information. I have so much of it. And then the limit as x approaches 2 of f of x is 10. So I'll get g of 10. And then g of 10 is -5. So that's the answer to this one. One more. The f of the limit as x approaches 3 of g of x. So we know that that is 9. And then f of 9 is 0. So that's our answer. So really what you need to know is sometimes you're going to be just like given notation like this. Sometimes you're going to actually have to like look at a graph, or you're going to have to do this algebraically. But you should only be finding the limit once, and then you should only be using function notation technically once. So now we're going to move on to looking at some graphically. Graphically is really similar to just be giving these values. So basically for this one is you are trying to find the limit of as x approaches -1 of f of x plus g of x. So you're going to find those two limits separately, and then you're going to add them together. So now you just have to find them rather than being given them. So the limit of f of x as x approaches -1 is 1. And then the limit as x approaches -1 of g of x is 5. So you just do 1 plus 5. Add it together, and you'll get 6. This one's a composition one, so it's trickier. So you're going to be doing, this is equivalent to g of the limit as x approaches 3 of h of x. So I'm going to start with the h of x function, which is over here. And I'm going to approach 3 from both sides. And there is no function value there, but the limit does exist because the left and the right side approach 2. So now I know that I'm going to look for g of 2. I'm going to go to my g function, and g of 2 is 0. So that is my answer. Our last page is a little tricky, but if I were to look at this one right here, I'm going to talk about my note in a second. As I were to look at the limit of f of x as x approaches 1, I might notice that it doesn't exist. And if I were to look at the limit as x approaches 1 of g of x, it also doesn't exist because the left side is approaching a different value than the right side is. And so it's tempting to think that this answer does not exist. However, That is not true necessarily. It could be, but I said up here, if either the limit as x approaches c of f of x or the limit as x approaches c of g of x does not exist, that does not automatically mean that the limit involving both functions does not exist. It just means that you can't use the properties we're used to evaluate it. So what you have to do if this ever happens is you have to find the limit from the left and the right side. So if this happens, you must find left and right limit. Now, if you want to know why, we don't have time to go over it right now, but there should be on Khan Academy some proofs that prove to you why this is true. So I'm going to start by finding the left-hand limit of these two things. So if I go to f of x and I approach 1 from the left, it goes to 3. If I go to g and approach from the left, it goes to 1. So the left-hand limit as x approaches, the left-hand limit of f of x plus g of x at 1 is 4. Now let's find the right-hand limit. The right-hand limit of this one is 1, and the right-hand limit of this one is 3, which equals 4. Therefore, because they are the same thing, we know that if the left-hand limit and the right-hand limit are the same thing, then that's the overall limit. So the overall limit to this is 4. If the other one, like the bottom one, had been 2, so if the left-hand limit was 4 and the right-hand limit was 2, then it would have been does not exist. But you always, if this ever happens, you have to check the left and the right-hand limit. Makes it trickier, but that's it. So thank you for those notes today. I will see you in class. Goodbye.